Good morning, one and all. In today's lecture, we will solve the numerical given on simply supported beam. Okay, but previous lecture we have seen again simply supported beam with UDL. Okay, but if you have given the movement acting on the beam, then how to solve the given numerical? How to find out the SFD? How to find out the BMD? Or in today's lecture we will see the new thing, how to find out the point of contraflexure, or what is meant by point of contraflexure. Okay, before going on that, see, so many students don't know how to draw the SFD as well as BMD. For that student, I have made here one table. Okay, with the help of that table you can easily understand how to draw the SFD and BMD. Okay, see, here you have to remember the 6 point. Okay, with 6 point, there is a first point. See, there is a loading is there, SFD is there, okay, and BMD is there. In the first point, get that no load between two sections. If there is a no load in between that two sections A and B, there is no load is given, then simply you have to draw horizontal line in the SFD diagram. Okay, if there is no load in between that two sections, then simply you have to draw horizontal line in the SFD. Okay, and what about the BMD? You should draw the inclined line. You should draw the inclined line. Getting? Then second point, if you have given the UDL load, okay, suppose in between that 2 points, here is a point and B point is given, you have given the UDL, okay, uniform distributed load. Okay, then you have to draw the inclined line in SFD, and here inclined line in SFD and parabolic curve in the BMD. Parabolic curve in the BMD. Remember that. Then third is that if you are getting the UVL load in between that 2 points, again we will consider, suppose you get this UVL, okay, uniform varying load between two sections, then here in the SFD you have to draw the parabolic curve, and here you will get the cubic equation. That's why you have to draw the cubic curve. Cubic curve means third degree curve. And next point, if there is a point load at a point, okay, if there suppose you have given the point load at that point, then you will get the variation in the SFD, this rise or drop at that point, right? What happened? This will be, you will get the, in the SFD, this point will be rise or drop if there is a point load. There is no change in the BMD. Remember that. Next is a couple at a point. See, in that figure there is a couple. It is also called as a movement. Couple at that point, there is no change in the SFD. When you draw the SFD, there is, you don't get any change. But what about the BMD? There is again you will get the some rise or drop. Rise or drop. That same point. Suppose B point, here you will get the rise and drop figure in the BMD. And last is a, if you are getting the internal hinge, then there is a no effect in the SFD and bending moment is a 0. You should remember that 6 point. With the help of that 6 point, you can easily understand in the SFD which line will draw, which curve will draw. Yeah, also in BMD. Then we will come to the point how to solve the given numerical. We want to draw the SFD, BMD, as well as they ask find out the point of contraflexure. What is the point of contraflexure? The point of contraflexure, the point at which in the bending moment there is a sign change. This point is called as a point of contraflexure. We will see the details. Before going on that, see this loading diagram is given. You have given the couple at the B point and C point. Also value is given. we want to find out the support reaction. Okay, first is a support reaction. How to calculate the support reaction? All of you know support reaction. Yes, see there are two vertical load, RA and RD is there. Okay, I will write here the upward direction positive and summation of Fy is equal to 0. Summation of Fy is equal to 0. Here is the two load in the vertical direction. That's why I have taken the positive RA and RD. Okay, don't consider the movement in the SFD. What is the definition of the SFD? It is the algebraic sum of the unbalanced forces. This is not force. This is already converted into the kilonewton meter. Means what? Movement, or we can say the couple. Force into distance. What is the unit of force? This is the kilonewton or newton. And what is the unit of distance? Meter is there. Meter is there. Okay, all of you getting? That's why we will get the RA plus RD is equal to directly 0. We will get this equation. Then what about the movement? If you have taken the movement, okay, clockwise is positive. Then check that summation of MA is equal to 0. Summation of MA is equal to 0. Then see that summation of MA is equal to 0. This 60 is going clockwise direction. Here we want to consider the movement. Yes, already converted in the movement. Don't multiply by distance. If it is there point load is given, then you have to multiply by distance. But here already multiply by the distance, so you have to take only that value 60 plus because of clockwise plus 80. Because of clockwise again. And what is the distance of that? RD is going again anti-clockwise. If you have taken the section after that, then check that this is going clockwise. We are going right to left. Minus RD into what is the total distance up to the 10 meter is given. 10 is equal to 0. Getting? Then check that this 60 plus 80, you will get the 140 divided by 10 is equal to RD. Means you will get the RD is equal to what? 14 kilonewton. Right? Once you have get the RD value, then put this value in that equation. What is the equation? RA plus RD is equal to 0. Then what is the RA? RA is equal to what? Minus 14 kilonewton. Okay, all of you getting how to calculate? Very simple. Okay, when you find out the SF calculations, then don't consider the bending moment. When you calculate the bending moment calculations, then you have to consider the bending moment. Very simple. Okay, then you will get the RA and RD. Then directly you can draw the given SFD. In that, check that here I will draw the 0 line. Okay, and mark the point. A is there, B, C and D is there. Okay, check that this RA is going downward direction because of negative sign minus 14. Okay, not positive. This force is at in downward direction at the RA, and RD, this force is at in upward direction. Remember that, don't confuse. RA don't act in the upward direction. Okay, RA is downward direction. That's why from the 0 line we are coming downward. Suppose here is a 14 kilonewton is there. There is no load. We have seen the table, right? No load in between that two sections. Then you should go horizontally. Okay. Again there is no load in between B and C. Okay. We are not considered the movement when you draw the SFD. We are considered the only forces. Okay. Again there is no load. Then we will go straight. Here is a 14 kilonewton. Yes. This is the negative SFD. When you write the calculation of the for the SFD, then check that SF calculations. I will write SF calculations. What is the SF calculation? SF at point A is equal to check that SF at point A, again you will get the minus 14 kilonewton, right? SF at point B is equal to again minus 14 kilonewton. SF at point C, again we will get the minus 14 kilonewton. Okay, and SF at D is equal to, again you will get the same value. Means A, B, C, check that. A, B, C, D, you will get the same value. If you have taken the just left side, you will get the only 2 points left and right for the A and D. A and D, check that. At the left side of the A, you will get the 0, and right side you will get the minus 14 kilonewton. For B point, means where is the couple is at, that point in the SFD, you will get the only 1 point. You will get the only 1 point. Then you should write here SF at B only. SF at B only. You can write here SF at left is equal to 0 and right is equal to minus 14. SF at D, just left, you will get the first and last point is 0. Check that. C point again here is the moment. You will get the only 1 point. Only 1 point at point. Okay, don't write left and right. Here you will get the 2 points left and right. Left and right. Okay, all of you getting very simple way. You can do the write the calculation for the SF diagram. SF diagram. Once you have write the calculation of SF, then you should go for the next step, bending moment calculations, BM calculations. Okay, BM calculations. To write the BM calculations, check that. I will write the BM calculations. Yes, what is the BM calculations? Then you have to write the bending moment at which point? A point. Bending moment at A point is equal to 0. First and last point, you will get the 0. Okay. Then where is the couple is at that point, you will get the 2 bending moments. Okay, one is the minimum and one is the maximum. Remember that. Okay, reverse of that SFD. Okay, here is the couple is at in the bending, you will get the 2 points. Then how to write that 2 points? Bending moment of which point? B point. Just left side. Just left side. What is the value of that? I will erase this. So we have drawn the SFD. We have write also calculation for the SFD. Okay. Bending moment at B, just left side. Left side means here you have to consider from this point. Don't consider the bending moment on the B. Just left side from this only. Okay, this portion. Then what is the bending moment? RA, we have getting that RA is negative. RA is negative, right? Bending moment at this left side minus 14, and you have to consider the distance up to the B. 3 is there. 3 is there. Means minus 42 kilonewton meter is there. Kilonewton meter is there. The next bending moment at B, just right side. Just right side. Check that. We are coming from that B right side, just right side, or beyond the B, just right side. Here we are considered. At that time, we have to consider the bending moment on the B also. Means what is this? Minus 14 into 3 plus 60. Minus 14 into 3 plus 60. How much you will get? 14 into 3 minus 42 plus 60 means 18. Yes, 18 kilonewton meter is there. Then next point, see there is again one more couple is there. Okay. So we have to consider the bending moment at C point, just left side. What is the value? This again minus 14 into up to the C distance 7 meter. Minus 14 into 7 meter. In between that, just left side, plus 60 is there. Plus 60 is there for the left side. Okay, you get the minus 38 kilonewton meter. Kilonewton meter. Then bending moment at C, just right side. Then again same up to this point, minus 14 into same distance 7 plus 60. Again we are coming just right side of the C. That's why we will consider the plus 80. Plus 80. You will get the positive 42 kilonewton meter. Okay. And last point, bending moment at D point, you will get the 0. You will get the 0. Once you have get all the value, then you can draw the bending moment. You can draw the bending moment. First, I will draw the here 0 line and give the name of that point. A, B, C and D is there. D is there. Okay. Then you should draw bending moment at point A 0. Bending moment at B, just left side, minus 42. Okay. Means A to B will get the value is a minus 42. If you have drawn the horizontal line in the SFD, then all the lines you will get inclined line in the BMD. Check that. I will consider here is a minus 42. 42 kilonewton meter is there. Then check that there will get the 2 points. One is the left and one is the right. Means minus again bending moment at B, same point, right side. We have the value positive 18 kilonewton meter. Means we are going upward. Okay. Suppose here is a 18 kilonewton. 2 points, left and right point. We will get the 2 points. Where is the movement is at? There you will get the 2 points. Bending moment at B point. Then bending moment at C point, just left side, minus 38 kilonewton. Again we are coming the downward. Suppose I will mark here. Okay. Approximately you have to draw. Don't use the graph paper. Okay. Don't waste your time. Kilonewton meter minus 38 kilonewton meter. At the same point, right side, then that 42 kilonewton meter. As we are going upward direction again, you will get the left and right point. Here is a 42 kilonewton meter. And at the last point, bending moment at D, you will get the 0. You will get the 0. This here positive, this negative, positive, negative. Okay, this is the BMD. Okay, what is mean? See, all of you getting how to draw the SF and BM for the given couple. Okay. Then what is the bending moment? Sorry, point of contraflexure. Point at which, check that. What is the meaning of point of contraflexure? Point at which in the bending moment diagram there is a change the sign. Change the sign means negative to positive or positive to negative. That point is called as a point of contraflexure. Point of contraflexure. Remember that maximum time in the examination you will get the question, find out the point of contraflexure. Find out the point of contraflexure with SFD and BMD. And how to calculate or how to identify the which is the point of contraflexure. Okay, here we know that distance, that's why no need to calculate the point of contraflexure. But here, exactly we don't know where is this point, from the A or from the D support, right? That's why we want to find out the distance of that point. First remember that what is the point of contraflexure. Okay, the point at which in the bending moment diagram, changing the sign, positive to negative or negative to positive. This point is called as a point of contraflexure. Okay, getting? Then I will consider the section here XX, and we don't know the distance. That's again we will consider the distance x from the A support. So we can calculate the we will take the bending moment at the A point, okay, or bending moment at the section XX. Then you will get the distance. When you taken the bending moment about the point XX section, then you will get the X distance. How to get the X distance? Check that you will get this one at the A point. There is a minus 14 kilonewton is there, right? Minus 14 kilonewton. I will write RA into X, RA into total distance up to the X. Okay. Then what? There is a one more in between that point. Here we get, right? Here is a couple is that in the clockwise direction. That's why positive 60. Positive 60 is equal to 0. Okay, is equal to 0. Then minus 14 into X plus 60 is equal to 0. Okay, then shift that side, minus minus get cancelled. You will get the X is equal to 4.285 meter. Okay, this is the X distance. This, where is this point of contraflexure from the support A? Okay, this 4.285 from point A. From point A. Okay, where we will get this point of contraflexure? From the A support at a distance 4.285 meter. That's it. Okay, all of you getting? Yes, student, you have to watch the video. I will upload that video on YouTube channel. You have to visit and watch. If you have any query, then you can ask me or comment. Okay, I will again explain in the next lecture. Today we will stop.